is the only video you will ever need. What if you could run Stockfish 17.1 right inside your Next.js app? No server, no lag, and a playable AI in minutes. In this video, I'll show you exactly how, using WebWorkers, React Chessboard 5, and we'll do some interesting refactoring and some nice tricks along the way throughout this video. So keep watching to find some of these tricks out. So create a new folder. So I'm going to call this folder chess app. You open Visual Studio Code or your IDE of your choice. Do you trust the authors of the files in this folder? Yes, I trust the authors. So run pm create next app at latest period, and choose ESLint as your linter and click on the defaults throughout. It will install these dependencies, and the install package, go to the package.json file. I'm using Next.js 15.5.5 as for the time of recording. So go to React Chessboard, their official website, by typing this, and it will lead you here. So click on this to go to their official documentation. Okay, this site can't be reached. What? Huh? So if the site loaded, go to the basic examples tab on the sidebar, click on drag to move link, and then click on the show code to list the code items, and just click on copy to copy the code. The next phase is basically the dependencies getting installed depending on your internet. So run this command to install chess.js and React Chessboard. So when they are done, this is how it will look like with pm. By npm users is npm installed. So run pm run dev to start this software, and go to localhost 3000. We get a blank screen because the project is compiling, and when we get 200 message, that means the application is loaded. So go to the page.tsx file, clear it, and run refce. So if you don't get this snippet, go to the extensions tab, okay, in Visual Studio Code, then run React snippets, and this is the extension by these, and basically then that was the extension, and you install it. So I'm going to rename this component to game. Okay, now I'm going to create a folder. Okay, this folder is going to be called components. So this is where basically all our UI stuff and elements and functions will be. So with this file folder, I'll create a board.tsx file and paste the code here. So in the code that you paste, you're going to see this render stuff. Just remove it from there and import this, and also remove that curly brace and create a board component. So, and also close it. Now in page.tsx, okay, what you do is to basically now import the board component, but that doesn't seem to work. So I'll export default board, okay, and now go back again to page.tsx and now import it properly. So now when we go to the browser, it's place random moves for now. When you play a move, it will play a random move. So what we are going to do is to just change the width and the height of our chessboard. So it's not really a major improvement. So I'll just make it 100 pixels. But for 100 pixels, we are not getting the best of detail as we want. So 500 by 600 is equally not great, but I'll make it 500 by 500 pixels. So now this is how it is, and the game is really playing well. So the next stage is to refactor our code base. Now you see this code is going to be very finicky. So the code that we copied from the React Chessboard documentation, okay, is quite messy and difficult to maintain. So basically spaghetti code. So to solve this problem, I'm going to create this folder called game functions. With this folder, I'll have a file called chessGameState.ts, and it's an interface. Okay, so you ask yourself, what is this interface for? So this is what it's about, is to pass the state here in board.tsx, the result of it, to other functions. So what do you think will be the functions that we are going to pass these states to? We'll find out. So right now, I'm going to the import chess from chess.js in the ChessGameState, and you ask yourself, what is the chess.js package and what are we using it for? So according to their GitHub repo, okay, chess.js is just a chess library for move generation, validation, piece placement, and all those goodies. So I'm now going to create the getMoveOptions.ts file, go to Board.tsx basically, and when I go there, I'm just going to basically cut this code, okay, and paste it in this file, getMoveOptions.ts. So when that's done, here is the question that comes into your mind. What does this function do? So it is for the highlighting of the squares, so all the legal moves on the board. So now I'm going to import square from chess.js. So what is this square type doing? Okay, so in the square.d.ts, if you actually put in the effort to run control plus click on it, it's going to lead you to the chess.d.ts file, which will have this type. Okay, so this type shows all the possible moves on the chessboard, so all the square names and ranks and files. So basically, this type, okay, tells chess.js that chess.js all the legal 64 square names on a chessboard basically. So with this in mind, let me continue writing some interesting chunk of code here. So chess game, we are importing it from chess, and setOptions squares, which is just basically a dispatch state, so something to fire changes to React, and we'll use this function in other files. So here is the interesting thing. What is this record for? So record, this type is just basically telling TypeScript that we are going to have a object inside our state. So go back to board.tsx again and remove the make random move file in this project. So now also go to board.tsx and create a file called onSquareClickHandler.ts and paste the code here and import all the dependencies that it will need. So in this case, square handler args, and then we are going to export default function onSquareClickHandler.ts handler function. So at the end, I'm just going to close the curly brace here. And from the next stage, we are just going to have the game states, okay, which is going to be the ChessGameState interface. So this is one of the functions that will pass the ChessGameState to. So all the important things that we found in our file, in this case, we are using most of it here. So the move from state, the set move from, all those goodies. Okay, so I'm just going to make it to be equal to the game state parameter. So let me change it. Now we are getting some interesting errors. Okay, because getMoveOptions. So let me just import square first. So getMoveOptions, we are getting some errors with it. Now in the getMoveOptions file, it's going to take 3 parameters. So we are going to fill it. So with these 3 parameters, we've already filled one already. So all that we need to add is just chess game and setOptions squares. And that's basically it. We just do it for the other places where we have the getMoveOptions function all across the board where it's being used. So I'm going to import it, but it looks like we didn't export it, so we have to export default getMoveOptions and use it here. Now let me just complete the process of just updating the parameters to basically solve all the syntax errors here. So remove the make random move function in this file, the onSquareClick file, and go to board.tsx again. You'll see something similar in the onPieceDrop function. Also remove it. So now the onPieceDrop function, I'm going to remove it and then create a file called onPieceDropHandler and basically write this chunk of code here, onPieceDropHandler, and then return the function. So that's it. Return the function onPieceDrop, and with onSquareClickHandler.ts, I just also have to add return there to return the function, and we are basically done with that file. So what we did for the previous file, that was the onSquareClickHandler. We are doing something similar to here, where we use the ChessGameState interface and satisfy TypeScript with some of these types. For example, page.handler. All these types are from React Chessboard, okay, and make TypeScript happy and make our code smart. So with ChessGameState, all these states, okay, we are just going to satisfy them with this. And when we are done completely, we just make it to be equal to game states. And I'll go back to Board.tsx again. So when you get there, we are actually going to now use the ChessGameState interface and actually let it to have the proper data, which is in this file. So all the states that are in this Board.tsx file were the actual sources, and we are just basically doing that. Now with the onPieceDrop and onSquareClick, I'm just going to create a variable called onPieceDrop, call the onPieceDropHandler method, and pass the game state variable that we created in here. And I'll do the same thing too for onSquareClickHandler. And now we have a fully functional chess game, where in this case we remove the random moves, so you have to actually control both black and white moves on the chessboard. And that's basically it for this program, but I'll just remove this. The next stage is how we'll use Stockfish. Before that, you have to install this dependency, so npm install Stockfish. So when you're done with that, you can actually follow along with the next stage of this software that we are building. So go to the node modules folder, okay, then look for the Stockfish folder and go to the source folder. Under this folder, you're going to look for this file, okay, Stockfish 17.1 light single with that code number you see there. So you ask yourself, why are we using this version of Stockfish? If you've done some in-depth research, you'll see various versions of Stockfish on the website, okay. So why are we using this version of Stockfish? So this version of Stockfish is pretty much overkill for what we want to do. It will absolutely destroy you in a chess game, basically, and you have no chance at all if it's at its max difficulty. And it will also destroy the GOAT, Magnus Carlsen, if it's at its maximum difficulty. So with that in mind, copy the file and go to the public folder and paste it there. So also look for the WASM file, okay, and copy that file. So when you copy it, go back to the public folder and paste the code here, okay, and that should be pretty much what you have to do for this stage. Okay, so here we go. Create the StockfishUtils folder, okay. So when it's done, you also have to create the constant folder under it. Now the next stage is to click on new file. So to create a new file, then have the file called index.ts in it. So in this index.ts file, you are going to have the stockfish part, okay. So this stockfish part is very, very important. So we are using it for a specific thing, is to just give it the location to where the JS file is, which is in the public folder of this application. The next thing is the ready timeout. So basically how long we actually throw an error when we connect to the engine and it didn't work. And the next thing is the calculation timeout. So the time we give Stockfish so that it will calculate its move. So if that time reaches and it's still not calculating, we can actually throw an error because, well, it's just keeping too long. And the next one is evaluation timeout. So how long we basically make evaluation to happen, and the depth of Stockfish. So the depth of Stockfish is quite interesting, okay, in the sense that the calculation can be pretty short, okay. So when the depth is very low, well, it doesn't have to calculate deeper and things go fine and it's not as smart, but when it is very high, it's pretty much at its best difficulty and it will absolutely destroy you. So the next thing is, what I'll do is create a stockfishGame.state.ts file, and I'll actually create another file again. In this case, go to your, in this case it's called UCI.ts. okay, UCI.ts, that's for Universal Chess Interface. And then I'll also have this file called stockfishEngine.ts. So go to this UCI.ts file, and in it we are going to have the pending message interface, so for resolve and then reject. So these are just for showing things on the console, basically on our promises. So when it's resolved, that means it's just one going to be a normal message, it doesn't throw any error. But for reject, we actually throw some errors on the console, and just helps us a lot when we are communicating with the engine. And we have the UCI options interface, so basically to limit the strength of Stockfish and have its elo and skill level. And well, if the elo and skill level is very high, it is going to crash you. Now when we go to the index.ts file again, I'm also going to actually import the pending message. So we have the workers. Okay, so a web worker is just basically to run script in the background. Okay, and it's very important because the Stockfish engine is very demanding. Okay, and this is how we start a web worker. And if you don't use a web worker, our application will actually freeze because the engine is very demanding on the CPU. So what I'll do next is to import pending message basically from the UCI.ts file, and that's pretty much it. So now go to the stockfishengine.ts file. Okay, so we are going to have a class called Stockfish Engine. Okay, this is basically where you have all the functions, basically all the methods that we'll need to use our web worker, like to start it, to terminate it, to customize the engine, all those good stuff. This is where we are writing the code too, and I'll explain everything perfectly as we are writing our code. So pretty much this code here, okay, states comes from the StockfishState class that we had the last time, and the constructor here is basically to make sure that when we create an instance of the Stockfish engine class, it will use the properties of the states which is in the Stockfish state class. And the interesting thing too is that the states that we've initialized here, we are going to use it across the important functions and methods in this file, so keep that in mind. So the if statement here is very important because we don't want to create multiple workers or multiple instances of Stockfish to basically break our software. And this code is just basically designed to communicate with Stockfish based on how long the ready timeout variable is, which previously we set to be 50 seconds. So if the communication is still persistent over 50 seconds, we just throw an error and we just say Stockfish initialization timeout. Basically, that's basically what this chunk of code is doing, so that we don't have to always wait too long for our worker to work. And pretty much here, I'm going to set up the web worker with the new worker function and also paste this code here. So this code is designed to start our web worker, which is in the Stockfish.js part. Okay, and the example was from the documentation that I showed you previously, and we are actually implementing it in real time over here with our web worker. So here we go with the message variable. So the onMessage is actually basically one of the properties that are in the new web worker object. Okay, and we have our callback function, and we have something that it has, which is event. Okay, so the event.data is just basically the response that we get from our web worker, and if the response is okay, which means the engine is ready, up and running and started, we can actually update the is ready variable to be true and basically stop the timeout, so that we don't reach to that limit and it fails, but we actually still have the worker running. And then we just return the resolve function. So I want to explain this code much clearly because this is a big backbone of our program. So This message variable, as I said in the past, is basically what the data that our worker will return to us. And this pending messages is just basically going to act as a queue, okay, for where we store these messages, okay, from Stockfish, so that we can handle them. So over here, the if statement here, we are using it to check if, well, the pending messages array is not empty. So when it's not empty, we look for the first item in it. And with the message that Stockfish provides, all that we just do is it's going to return a string in the form of a PGN, whereby you have best move and then, well, the PGN or of the moves, so maybe e4, e5, e2, e4, something like that. Then when it gets that result, all that we just go and check is that we are looking for the best move string in it. So if it has that string in it, all that we just do is to just, well, look at the pending messages array again and then delete the first item that we see there, right? And then we compare and check whether, well, it really match with that format. So the message match with that format, and then what we just do is to just extract that information from there. So that's the next string after the text called best move, which is going to be the PGN, and that's pretty much it. So this code is just basically to handle the error from our Stockfish engine in case that happens. And then the post message and for here is just to basically know when the engine is ready. So all those previous steps in the initialization of the engine is to just basically to ensure that when you communicate with the engine, nothing goes wrong. So if you doubt me about the UCI commands, here are they in the documentation. This is how you pretty much communicate with Stockfish and pretty much most common engines nowadays. And we just have the card for exception handling, just in case if something goes wrong too again. So I'm pretty much also going to close this aspect of the code and then we focus on a new method that we are going to write. So this is the new method we are writing, which is setOptions. So the UCI options and the options parameter basically is just basically the properties that are in the UCI options interface, and then we basically check if our workers is not active or it's not ready. So if those conditions are not there, we just throw an error that, well, our engine is not initialized. And in the UCI options interface, okay, there's a property called limit strength, and that's what we are using for this aspect of this code. And if that comes into the picture, okay, and it works, all that we just have to do is to just set up the UCI command needed to, well, actually limit the strength of the engine. So let me continue to scroll and let's see the other options. So these other options are quite clear. Okay, one of these commands is just to reduce the elo based on the value that we provide in the options.elo interface, and the other one too is to just have our else statement. So if something goes wrong with limiting the strength, we just stop limiting Stockfish strength. Okay, and then the lower command there is just to, well, fulfill the conditions of limiting the skill level of Stockfish. So all the parameters or the options that we are given are in the UCI interface, and that's pretty much it for the set options method. These are just basically to configure Stockfish in a way that, well, its strength to be limited. Oh yeah, we have the best move method, so I'll just resolve some errors. And the devolve cannot find new name default depth, so what I'm just going to do is to go at the top there and then just import default depth. So that's from the constants, okay, that we had in the other file. So the next thing is to just use the return statement for now to solve the issue here so that we will not get any errors. Now for preciseness, FEN is just basically the string that we are going to give on the game state to Stockfish, and then the depth is how long Stockfish will calculate its moves. Okay, so basically we give Stockfish an FEN, and then it gives us the results back, okay, of the best move. Okay, so this code is basically to clear our timeout when, well, either a correct move happens or an error happens, basically, and puts that data in the pending messages array. This is pretty much what it does, and it's very important since we don't want to keep communication to be infinite. Basically, we are getting an error with the calculation timeout, so all that I'll just go and do is to basically just import calculation timeout from the constant. Then now we also get this code, so if all those stages were done, we are just going to send these UCI messages to Stockfish, basically giving it the position and also the depth at which it should calculate based on the constants or the variables that we had or the parameters that we passed, basically over there, the depth and then the FEN. That's pretty much it for this function. This method, method, mixing the names up, not my fault. Needs method to basically destroy any activity in the web worker and reset all the states to be empty because, well, we've stopped our web worker and we don't need those information there. And then we'll have our initialized method, okay, so that we can basically verify that, well, our web worker is active. You'll see us using it very, very soon in other files, so just keep that in mind. You have to go to the chessGameState.ts file, okay? So when you get to this file, you're going to do something interesting here. So what I'm pretty much going to do is to use the StockfishEngine class here. So an instance of it here is AI thinking, and then set is AI thinking. They are just basically state that we will implement in Board.tsx, and I'll import the StockfishEngine class here. Pretty much that. And now you have to go to Board.tsx, as I said, so that we continue our code changes. Now when I get to this file, I'm just going to remove this comment, then just have the is AI thinking state here as we did. So basically all the things we implemented in that interface, we are going to implement it here. So I'll have a variable called StockfishEngineRef, and then it will have the type as the StockfishEngine class. So pretty much this code here, and all that I'll just do is to import it. So StockfishEngine, and that's it, pretty much that. So the next phase is to use the use effect hook, whereby I'll have my StockfishEngine class created here in the engine variable, and then basically with the use ref hook, I'm just going to make its current to be the engine variable that we set here, and then I'll just go here and then import use effect. Pretty much clear, right? So now the next step is to use the initialize method that was in the StockfishEngine class. That's how we will use it to start our engine, and we are actually putting it in the use effect hook because, well, we want it to start when the DOM loads, basically load the engine. So because it's a promise, we just basically configure the engine, okay? It can either resolve or fail. So in this case, we are using the setOptions method, and we are just limiting the strength of the engine and just catching any form of errors that can happen. And now this is the cleanup function that mostly is in use effect. So in that location, we are just calling the terminate method that is in the StockfishEngine class to, well, terminate the engine and clean up use effect, okay, when it's not really needed. The make AI move function. So the first if statement that you see here is basically the conditions in which the AI cannot play a move. So in this case, when our engine is not really loaded or initialized, when the AI is actually thinking of playing a move, that means our web worker is working around that time and Stockfish hasn't returned its move yet. Or conditions whereby, well, the game ended because of checkmate or something. That's when Stockfish cannot play a move. Now, the next if statement is more or less to check if the AI is what? Not black. So my default configuration here is that the AI is always going to play as black. I'm assigning you to basically improve upon this code base because, well, I'm making it as bare bones as possible without a lot of features to make you be able to make a more brilliant application than this intentionally, and then basically update the set is AI thinking state to be true. That means the AI is thinking around that phase where it is making a move. So now I have this code whereby we are using the getBestMove method from Stockfish, right? So with getting the best move, all that we just do is to give it an FEN, and that's what we are doing for this part of the code base. Okay, so the FEN is the game.fen, so the game that we are currently playing. So any moves that you make in real time, okay, that's the FEN that is going to give Stockfish, and then it will reflect then the move that it will play back, and then it continues that cycle. So I'm always going to catch any forms of errors with the error, with try catch statement, and with error. And what I'll just do is quite straightforward. So the from and to is basically these variables is how we'll make sure to make Stockfish to actually put the move on the chessboard. Okay, so from is the starting point, so the first move from our FEN basically. So the best move is tens, and then the 2 is the move that Stockfish is actually going to play, and then the promotion is just basically how the piece that Stockfish will promote to. So that's the variables that you are seeing here. So if Stockfish doesn't really return anything at all, you are probably going to throw the undefined type. So that's basically that. So it's error handling in a way. Now we are implementing the chessGame.move function, whereby we are just using the from and the to variables, and this will make sure that the move reflects on the chessboard basically. And we have the set chess position state. That's actually what will update the chessboard, okay, the latest FEN. So now I'll just handle the errors by just throwing an error, Stockfish move error if there is something that goes wrong, and then by default, if nothing is going on, the AI is not thinking, so we make it to be false. So now I'm going to paste this chunk of code. So this, we are just basically updating the ChessGameState interface with the needed values that we added there previously. So that's why you have the StockfishEngine, it's AI thinking, and set is AI thinking variable. So go to the onPieceDropHandler.ts file. We're going to do some interesting refactoring here. So over here, I'm going to create the make AI move function here. So basically the onPieceDropHandler will return, we'll take this method, this function, make AI move. The one that we created in Board.tsx is of the type void. Well, I'll just have to remove the semicolon here. Then after that, with the game state variable, all that I'll just do is to just set its AI thinking to be there. And then when I do that, I'll just check if the AI is thinking. You just return false. Okay, so you can't play a move when the AI is thinking. That's what it will be for here. Then over here, I'll just have my if statement, which will just basically check if the make AI move method has happened. So if that's it, we just call the make AI move function over here, and then we use the calculation timeout variable and divide it by 3 over here. Go to the onSquareClickHandler.ts file. Okay, that should be it. Then now over here, we are going to do the same thing, make AI move, and then it's going to be a void function, and then have there is AI thinking state in the game state. Then I'll go here, then we just, if the AI is thinking, we just return, and then we do the same thing here with the make AI move. And now I'm going to run pm run dev. Okay, so the project is compiling error. What?
Oh shit, here we go again.
Okay, so the next phase is go to the board.tsx file. In this file, I'll now add the make run AI move function as the parameter for this function, and also the scene entry here to settle the issue. So let me run pm run dev again. And let's see the results we are going to get this time. So I'm clicking, compiling again, and hooray, we get our chessboard now. As you can see, Stockfish is playing its moves. You get there, it's AI thinking text and all those goodies. Pretty nice, right? So I castle. Now Stockfish here is not at its full strength. Well, my challenge to you is to create some form of slider to adjust the strength yourself and add other features. I want to make sure that you are able to be creative and be a real dev by adding your own features to the software. That's why I intentionally made it to be as bare bones as possible so that you have the creativity to improve this software. Nice moves, actually. Let's see. I play rook to e1. Let me take the free bishop, basically. And it took my piece, so it wasn't necessarily free. Let me play bishop to c4. Look at the move it's played. If you like this content, please like and subscribe to this video and subscribe to my channel. In the comment section, you can basically recommend more content for me to provide to you guys, software wise, any form of software that you want me to build. Pretty much anything, as long as I can build it, I'll do it for you guys. See you in the next video and have a good time.